Hey guys, Ricky with DV Laserworks. I hope you all are having a great day. Today we're going to talk about temperatures. And a lot of it is a misnomer. Uh, People think that um, when it comes down to laser engraving, there's only so much you can do and figure out. Well, we're going to be in this episode, and what I hope to do, and part of the 101 series is figure out what temperature lasers run at. And you're probably wondering, well, I've got a CO2 or I've got a fiber or UV. That's not important. Well, it is to a certain extent because when you are, oh, I don't know, when you're doing a mass production of stuff and you're doing, say, a bunch of coins, this is, I think, is aluminum, there's actually a little bit of heat that gets built up into it. Um, Some people, they'll use something like this, kind of a heat sink type of thing, and it works. I mean, you're getting that airflow going across the fins, and it's drawing everything down. Well, you have to look at those types of things. Then you have what our project today is going to be, and I've got a sacrificial brake pad. I'm not going to be working on the rotor surface. This is a non-slotted, non-ventilated type of brake pad, but we're going to try it out and see what actually the temperatures are going to be. I mean, you can't really use something like this to take a temperature for a something that you're engraving or basically deep engraving into, and you can't use this neither. I mean, both of those are for medical purposes. Now, what I have here is something that I got over at Lowe's, and you could probably get something either off of Amazon or what have you, and it's one of these. Now, this is good up to about, if my glasses are right, about 300 degrees Celsius, which is quite a bit of temperature difference. Basically 608 degrees, um, somewhere in that time frame. I use this one for whenever I'm smoking meats, so I know it's very good up to 200 degrees, 212, depending. So I can take that ambient temperature. Also, if it doesn't work for your applications and you have cats, this has a laser on here and it drives them nuts, and including dogs and kids, but I digress. Um, so what I'm going to do now is we're going to switch positions, and I'm going to I'm going to clean a piece of the rotor and show you. I've got a file up on the screen that I'm going to be doing onto this rotor, and we're going to check out the temperatures. Before we even get started, I'm going to take a temperature real quick, and it says 76.8. So, that's what my garage is right now. It's the surface temperature of the metal. So, we're going to while I'm doing this engraving, I'll probably do a couple of stop points and then try to do a actual deep engrave. This is about probably a little over a quarter of an inch thick, where it mounts up to where the axle goes up to. So we're going to be looking at that. So I'm not going to get too deep into it, but we are going to get deep. While I'm doing the cleaning, I'll take a temperature of it. And since I won't be able to show you the actual camera angle, I'll probably put it up somewhere up in this area to show what the temperature was whenever I cleaned and while I'm engraving. in different points. So bear with me. But I'm looking forward to this. I have not tried this yet. It's something that I got, I've actually been burned on. Yes, pun intended. Whenever I'm moving something that I have engraved to put on something else, because time is money and money is time, you know, it's something that I need to know. So we're going to try it out on this brake rotor, and I'll see you here in a moment. All right, now we've got this kind of set up right here. Um, so now we're going to look at how everything goes on this. So it's, it's about a 2-inch type of deal. Pull up my screen real quick, and we will go from there. So I'm going to do a block. And this is going to be 2 inches high. By 1717. So I'm just going to do up a 2-inch by 2-inch. There'll be some going past the holes. I'm not going to be too concerned about it. All we're doing is removing the rust. Okay, we have gotten it down. That is the square that you're seeing is the area that we're going to be engraving. As you'll notice right up here, we'll be putting some of it up in that area. Not too bad. If I wanted to, I could shrink it down, just put it right into this area, because technically this area is my focus area. So let me go ahead and swap out real quick, because we are going to be doing a deep engrave. Now this is going to be 14 inches of speed, 100 power, and a frequency of 20. And everything's looking fat, done, and happy, just like me. And there we go. We are off. Now this is 10 passes. And it's already jumping to 84 and a half. Now this is a crosshatch, and it's still the first pass. Temperature isn't getting up as high as I was expecting. And right now it's at about 94 degrees. There's a lot of uncertainty in engraving as a whole. And it could be just it could be anything. It could be the material. I mean, this setting is for steel. It isn't for what have you. As you can see, it's getting a little bit darker because I raised up the height on it. Because you want something that sounds like, for lack of a better terms, bacon sizzling. You want that sizzling sound to happen. Now, like I said, this is going to be about 10 passes, and it's going at an interval of 0.001. Now, I can change that to 0.7 or 0.027, and probably make it less aggressive, but aggressive nevertheless. I mean, right now we're at about 83.3, 83.5. Now I'm looking at something that's away from the actual engraving site, and it's coming out at 76.4. So you can see the difference, the change between what's being hit and what isn't. But you have a general idea as to what it actually is doing. Now, the one thing about the intervals, the smaller it is, the longer it actually takes. And that is one of the things that most people don't understand. But you also get a cleaner engraving if you go as low as like 0.001 inches as opposed to 0.003 or 0.0027 or even larger. But it's mostly because it's such an aggressive engraving point. You'll also notice that the line is changing in its crosshatch. So there is away on light burn to do what you want it to do. And what we're doing is we're confusing the metal. So there's an angle increment that we are using on this. And what you're going to do is, let's say, if you count the actual passes, think of it this way: we're doing 10 complete passes, but we're doing it as a crosshatch, so it means it's passing twice over in each pass. So you have to kind of confuse the metal and its burn pattern and what have you. There's a spot on whenever you click on where your custom layers are, and it has a number of passes. You have like whatever your scan angle, that means whatever angle you want to do, whether it's 0 or whatever else. You want to start it at 33, you're able to do that. But down below that there's angle increments. And what I did was I knew that there was going to be 2 passes per pass, and I went ahead and took 360, divided it by 20, and I got 18, which is what this angle is changing up every time it finishes one pass. So it's adjusting its angle 18 degrees every pass. And this just kind of helps even out the actual engraving. It kind of confuses the metal a little bit. Now this isn't getting too hot. I'm seeing it at about 98.4, 101. It's bouncing back and forth. So as it's digging into it, it is imparting heat into the metal, which is what it's supposed to do. If you think of a cutting torch, when you go and you cut off, following your chalk line or what have you, you have to use heat in order to cut that piece of metal or that steel. Lasers are the same way. It's basically, you've got an intense heat in a focal point, and it's taking away little by little metal. So this is also, this is a beautiful thing as far as that is concerned. Coming in with a temperature check. And it's still hovering around 100. And I think it's mostly because of the material itself. It's designed to dissipate heat. And when you have a little bit of air going across it, it will change what it's doing. So this may or may not have been a good decision to engrave. But we're going to let it run its test and see what we can do. So we're almost getting to the end of it. Still got quite a few passes, even just for 10. I'm going to do after this gets done, I'm going to do a cleaning pass and see if I can get really, really invasive into it and aggressive in the actual engraving of this, and see how deep we can go. So, what have we learned? Well, brake rotors aren't exactly the best thing to learn about heat, but we now know why they use the metal that they use for brake rotors. It dissipates heat rather quickly, and if you have a slight breeze going across, beautiful. I still do believe that if I went and engraved this, and this is probably aluminum, if I remember right, we would be able to have a little bit of a temperature difference on there. As I said before, everything, the bigger the piece and the smaller area that you're working on, the more it will dissipate, the heat will dissipate throughout the metal. Didn't see anything dangerously high as far as temperatures were concerned. Everything was tangible, and there was no real issues with that. So what we need to figure out next is, and what I'm probably going to try to do is, I'm going to try to borrow some steel and lay it directly onto the bed of my laser and figure out what's going on. I do believe that this right here should be in all of our toolboxes next to a laser, whether you have a CO2 or a fiber, and that way you're protecting yourself. So even though we didn't get the results that I was looking for on this, I think that this is a good start for what we are capable of doing. Again, this is still, the job is still going on. It's something I'm just going to goof off with a little bit. I don't think that this is going to get in as deep as some things, because I'm only running 10 passes. If you're running, like, say, I don't know, 100, 200, 500 passes, and you're doing a 3D relief, it's going to take a while, and we're talking hours to be able to do something like that. I'm interested, but I'm not interested in something like that. Just know that having something like this in your arsenal, whether you get it at your local hardware store or you get it on Amazon, whatever the case may be, I think that this will help you out dramatically. And I think this is an essential tool for your laser engraving. But yeah, just for those of you that laser engrave, try it out. I mean, it's good information, especially if, I have burned myself on it. And Of course, I was stupid, but sometimes you figure, wow, there's wind blowing across it, it'll dissipate. Whether you're doing um, black on stainless steel or what have you, or even just, like I said, 3D relief, there is gonna be a reckoning when it comes down to temperature. Lasers depend on temperature to work, and there's no such thing as a cold laser to safely engrave something. You still have to ablate that metal. But I hope you all are having a great day. This is Rick the Ooge with DV Laserworks, and I'll see you all on the next one.